All right, everybody, we're going to get going here today. So welcome. This is our second episode of the Process Tidbits webinar. First off, I just want to throw another little shout out here to our Axatronics company. We're just getting going with them. They're a great company, downstream automation. They have a lot of stuff in the robotics field, and that's where they specialize in getting your downstream products moving towards moving out your door. So Axatronics, if you haven't checked them out, look them up. They're a great company. We're proud to have them in our Brown Machine Group family. This is going to be our Back to the Basics Part 2 webinar. I'm going to be your presenter today, Alex Strobridge, a process engineer. I started with Brown Machine Group in 2018. Some of my industrial experience, 10 years as a process engineer, and now I have 2 years in the tooling and tryout as a service representative here with Brown Machine. I got a good mechanical and electrical background, and I've processed a lot of resins through the years, so I'm going to help you out today. A little introduction. In this presentation, we'll be starting at the basics of the trim press setup to help answer some of the questions you may have. Use the comment message window to ask questions throughout this presentation. So instead of trying to vocalize your questions, go ahead and throw them on this comment session. We'll be comments board. We'll be trying to answer those questions throughout the presentation. We've got more than just me online, so if we need to, we'll pull somebody else in, let them talk a little bit. Try to get some of our other Brown Machine voices out there for you to hear. Provide us with feedback so we can provide the best service possible. Please chat or email us your feedback at sales@brownmachinegroup.com. Now, this is going to be big. You're going to hear me say it a lot through the presentation. We want you guys to reach out to this sales@brownmachinegroup.com. It doesn't mean that we're trying to put you in touch with a salesman. It's just our way of gathering the people that have gone on this webinar and getting the info out to them. So if you email us at sales@brownmachinegroup.com, we'll be able to filter you to the best person possible to help you out. Ask for additional information on BMG's service offering to receive a call from one of our trained professionals. They would be happy to show your company our easy-to-follow programs, included but not limited to on-site training and PM, remote services, part stocking, and more. Let BMG work with you to keep your operation efficient. So this is going to be a big one for us. We have some great programs going out. This on-site training and PM, that's huge. We're doing these CAD drawings big on your machines. It shows you exactly where, when, how to take care of your machine, along with these a large checklist that go with your 24-hour shift to shift, 200-hour annual PM. They follow through the whole thing, and it's a big training program. I'm one of the main guys that goes out and does this. So if you purchase this product from us, you might just see me walking in your door to come and help you out. Our remote services is big too. We do a lot of stuff online through the E1 systems. We're able to access the machine, help you out, help you diagnose and troubleshoot stuff. Before we go any further, I just want to take a second to show you this chat bubble. If you don't already know how to use this, should be at your lower portion of your screen. Some of them may actually be at the top, but you should see some circles here. You'll see participants list or a chat bubble. If you click that chat bubble, you'll be able to pull up the screen. And we want you to chat to everyone, so that way we can all see it here at the Brown Machine Group, because like I said, we have multiple people online to help you out. So go down, click the center there, click the chat bubble, pop it up so you can kind of pop in your questions. And if you're still having trouble with that, just write down that sales@brownmachinegroup.com. If you're not able to send a chat in, and just email us and we'll be sure to get back to you right away. In this segment, we're going to be talking about the trim press. Now, a lot of this is going to have to do with our horizontal trim press. Is one of our main products. We do have some of the stuff in here that's going to follow through all of the, setting up canopies and guides and stuff is going to follow through the majority of what you're doing. So it's going to kind of cover all of it, but we do dedicate a lot of this first portion here to our horizontals. First, I want to go over some of the quick tool change features that we have. First, we have the side tool change. The tool is inserted and removed from the side of the trim press via a tool cart attached to the press. Now here we're actually seeing a vertical station. They work similar. This one's gonna have this tool cart here. It's on wheels. It's got rollers for your tool. You're able to roll this up to the press. We use 2 pins to push it into place so it's safe and attached to your machine while the tool is on it. And then we're just going to slide that off onto the plat. Now, if in a horizontal setup, we're typically going to want to have the tool cart pushed up to the machine, and then we'll have a lift table inserted in here, and we'll use an air motor to lift the tool into place, and then you're able to bolt it to the movable platen and lower your air table and get it set up. If you see me look down from time to time, guys, I'm trying to read a presentation off the one screen and then check the chat through the other one. Just trying to make sure that if you guys pop in any questions that you can do at any time, I'm able to read them and try to get answers back to you. Next, we have the under the press tool change. The tool is inserted and removed by dropping the tool below the press. After ensuring the platens are within parallelism 5,000 max and all the machine surface are cleaned and stoned off, raise the tool into the position with an approved lift method. Now you're going to see this a lot, this cleaned and stoned off. We recommend, we encourage, we implore you to please clean and stone your tools and your platens off each and every die set. Some people think that there's not a lot of buildup that goes on between die sets, but not a lot of buildup over time equals a lot of buildup. It doesn't take much to throw these out. When we're saying 5,000 max from corner to corner on these stations is the max you can go, it only takes 5,000 buildup, which is barely anything to get these out of center. So we really want you to clean and stone the dies and the platens every time. You're gonna hear me say it multiple times in this presentation. Next, we have the stationary platen tool change. The tool is inserted and removed while attached to the stationary platen. After ensuring the platens are within parallelism, 5,000 max, and all the machine surfaces are cleaned and stoned off, attach the stationary die chute to the stationary platen. Do not tighten the bolts, but ensure the bolts go in freely by hand all the way. Mount the moving platen to the trim press and tighten the bolts to the recommended torque. So the reason we do this on the stationary platen, we want that to be bolted down just finger tight, and then on the movable platen, that's where we're going to torque first. Because what we're going to want to do is open the tool, and then we're going to want to enter the punches and dies to set that stationary side with the moving. Because as that moving platen is going, if anything is off, as it comes into the stationary die, it naturally wants to go to the same place every time. So if it's dipping at the end, if it's lifting at the end, if it's dropping at the end, if something's just a little bit off, if we allow that to float into place on that stationary, it's going to go into the same spot every time. So then when you do fix your machine, or you get everything back up and everything's nice and straight, we can still use the same tooling. We're not going to cause any further damage because we're always going off that method of tracking it into place using that movable platen. Tool alignment sequence. One Segan or key on one side. Enter the punch or die, or enter the punch before tightening. Segans or keys are to be pre-aligned to the tool, so the stationary bolts are centered in the hole and do not influence the location or alignment of the punch and die. Now we say one Segan or key on the side. So we only want to align one side, the stationary or the movable. Typically it's the movable because that's what we're going to bolt down first. We want to key that side, not the other side. If you key to two different objects, they're going to be in two different places. So we want to key to that movable side and then float that stationary side in so we're remaining the same. The tool installation. After ensuring the platens are within parallelism, 5,000 max, and the surfaces have been cleaned and stoned off, install the new die set into the trim press using one of the previous methods. Unlock the moving platen Segans by attaching the air supply. Slowly roll the platen up to the die chute, making sure the Segan knobs and Segan locks are in line with each other. Once they are mated, lock the Segans by removing air. If you wish to add bolts to the moving die chute along with the Segans, now is the time to do so. Now the stationary shoe is in place. Run bolts into the stationary platen side of the die chute. Personally, I generally like to use the Segans, and I can just add one or two safety bolts. Some people like to add all the safety bolts. It's completely up to you. Do not tighten the bolts, but ensure the bolts go in freely by hand all the way. Remove the die straps from the die shoe. Roll the press to the full open position. Inspect the punches and dies for any debris or burrs, and roll the press slowly close until the punches enter fully into the dies. It should now mate up smoothly with little to no resistance. And really put some emphasis on this little to no resistance. You shouldn't have to pop these into place. If there's something wrong, we need to check that out. Lock the flywheel in place using the air brake or safety pin and begin to tighten the stationary shoe bolts, starting in the center and working out in a star pattern. Now, this is really important. You really want to start in the center of these chunks of steel because even though they're big and you think that they can't twist or bend, they can. And we want to make sure that that steel is laying flat across that face. These tools are huge tolerances. I mean, we have the machine capabilities running down to 10 thousandths. So we really want to make sure these are flat. So you want to start in the center and work out in a star pattern all the way out to the ends of your tool. Next, we're going to go into a little bit of the mechanical setup. This starts with setting the proper platen stroke for the product being trimmed and setting of the treadle and sheet guides. Adjustments to the canopy and nip wheels need to be adjusted also, along with pressure settings such as sheet drag, pusher fingers, and nip wheels. The platen stroke. This is affected by the throw pin in the main flywheel. Stroke can be adjusted from 4.5 inches to 10.5 inches on most machines, and some special machines go out to 16.5 inches. The crank throw is adjusted by disconnecting the main connecting arm from the throw pin. So you have the main connecting arm. This is going to be this main arm, and then this is going to be your throw pin. So what we're doing is we're going to take that arm away from that throw pin. You're going to remove the main bearing block. This outer block is going to be your main bearing block. Remove the 6 to 8 bolts that hold the throw pin into the main flywheel. Using the jack screws, remove the throw pin from the flywheel. Yeah, this is going to be your throw pin. Then move the throw pin to the desired stroke. Closest to the center is 4.5, so the closer we get to the center of this main flywheel is going to be a shorter stroke. And 10.5 being the closest to the edge. So if we move it all the way out, we're typically going to be at 10.5 inches of stroke unless you have a specialty machine that can go up to 16.5. And now you just reassemble it back together. The easy adjust crank throw system is adjusted by moving the press to the full close position, disconnect the counterbalanced link arms, remove the 6 to 8 bolts that hold the throw pin to the main flywheel, remove the center throw bolt, and use the adjustment bolt to move the throw to the desired stroke and reassemble. This is just something that we've put in place on our systems to try to make this a little bit easier and you don't have so much disassembly. If you want more information on that, because it's kind of a great system to have, just email us at that sales@brownmachinegroup.com. We can get you some information out on those. I see we got a couple of questions coming in here. First off, how do you adjust the parallelism on the platens? Is this something that has to be done on every tool change? Yes, you definitely want to check this on every tool change. On this next slide here, we're going to get into a little bit more of that, and I'll kind of reference back. But generally what you're going to see is up in front of this setup here, you're going to have the outer sleeve to the main arm, and there's going to be 2 to 4 bolts on each end of that sleeve. You will loosen those on each side of your machine, and in unison, you'll want to turn those to get your parallelism right. You're going to get your platen opening and your parallelism very, very close by just those sheaves. There's just those outer sleeves of your shaft. And I'll hit on that just a little bit more here a little later in the presentation. Next question here, can PDF copies of this presentation be made publicly available? We're going to shoot you guys out a link here. We're going to get this up on our YouTube channel. So we're going to get you all this information at your disposal. You'll be able to go back through it. And if you want like full training, full on start to finish presentations, because we have a great setup. I've got 202 pages of presentations that come with the training. So look at our service and PM programs. You get me out there for a few days to go over your line, PM it, check it, see what could be good, see what could be bad. We do oil testing. We do all sorts of things along with an extensive training, both in classroom and on the floor, to try to help you out with that. Shut height. So this kind of goes along with that first question there. Is the parallelism on the platen something that needs to be done on every tool change, and how do you do it? So really watch here, because this section here is going to show you how to do that. This is the distance between moving the moving and the stationary platen. This is affected by adjusting the connecting arms. Installed on some of the newer machine is a fine-tuned feature for small adjustments to achieve parallelism. Now I'm going to jump back here one slide because I want to show you this fine-tune feature. It's a great feature to have. So this is our fine-tune feature here, okay? And what it is once you get that parallelism really close, we can just loosen our 4 outer bolts, and you can see here the springs that are holding tension on this plate. Then we're able to move our wedge to adjust that platen, okay? Now, one note here I got from one of our service representatives, Todd Kite, is that this wedge has been known to just keep moving down when people are adjusting it. They'll just adjust it further in and further in and further in until they get it bottomed out. And this is not something that we generally want to do. So if we're trying to use this fine-tune feature, what we want to do is at each die set we do, we just want to crack our bolts loose. Let's bring this back to a central location, and then you start the process over again. We don't want to ever extend anything and pinch it at the bottom. We want to try to keep everything in a nice working order. So it's a good little tidbit for you to have. Thanks for that, Todd Kite. Next here we have, this is achieved by loosening the bolts that tighten the connecting arm sleeve to the connecting arm screw. Using the spanner wrench provided, turn the sleeve to either close or open the gap between the platens. It is recommended to move both arms at the same time. One full rotation is about 125 thousandths. When desired gap is achieved, tighten the bolts in the connecting arm sleeve, rotate the main flywheel back to the closed position, and check for parallelism. Now, we want to do this because when you're loosening the outer sleeve, okay, you're letting all those threads in the screw, the main connecting arm screw, you're letting them all kind of relax and move a little bit. Okay, and that's what allows you to be able to turn it with a spanner wrench. So we want to move those in unison, both sides of the press. We want to turn. Okay, one full rotation is 125 thousandths approximately. What we want to do then is we want to get it close, maybe check your parallelism and see how close you are. Tighten them down a little bit, check, tighten them down all the way, then run your press to full close and check parallelism to make sure you've got it right. If not, you might have to loosen up and just adjust a little bit to get it back in, tighten it down and repeat. And this is something that can be made much easier if you install our fine-tune adjust on there, because you're able to really just crack those loose, dial it forward a little bit, and get them even, get that parallelism right, and go on your way. Next, we have a little tidbit here about the canopy. The canopy should be positioned so that sheet feeds freely into the treadle at startup and does not kink during operation. Okay, what this means is you have your treadle openings, right? This is where your sheet's going to go down and starts its straight descent into your tool. Now, above it, you're going to have your canopy on our horizontal presses. You're going to have your canopy. Now, what we try to do is set this so your treadle stroke here is going to be even side to side of that canopy. What I like to do is I like to run the platen to the midway of the stroke so that when I feed my sheet in the center, I'm feeding it straight down. That way, when it starts to open, it's feeding open. When it's closing, it's finished feeding, and it brings it up to the tool, the line, and you're ready to punch out that shot. Set in canopy guides and anti-backup. So in this next section, we're going to talk a little bit about the in-feed guides, the nip wheel gap and flow control, nip wheel pressure regulator, nip wheel speed control, camera pressure setting, canopy guide setup, anti-backup function, and the loop eye setup. You guys got any more questions kind of on that past segment? I don't really want to jump too far ahead here if you're kind of sitting here still wondering about something in the past. Feel free to shoot us our questions. If you feel like you need to go much more into depth or you're just not getting it at all, please contact us at our sales@brownmachinegroup.com. Let's get in touch with you. We can talk through it. We can maybe get you some information and try to help you out. So the in-feed guides, like the former, they need to be set square and positioned parallel to the canopy nip wheels. So this is your entry point into the machine. We really want to make sure this is straight. Just like your former, if your rails aren't straight to your tool, you're not going to get something presentable for your trim press. If your canopy is not straight to your tool, you're not going to present that material straight into your trim press. If they are set too wide, it can lead to tracking issues. If they are set too narrow, it can lead to buckling and tracking issues. So we don't want this stuff too wide to where your sheet has free roam side to side, and we don't want to buckle up that sheet. What we want to do is we want to give it just a little bit of space, and it's dependent on material, but typically it's 1/16 of an inch per side, just a little bit of space, and then we want to have those sheet guides going up that canopy close to your product, not on your product. Okay, we want to guide the sheet in. We don't want to force the sheet in. I see a question here from Brian. How do we tighten the back open? I'm just not quite sure what you're asking me here. I'm going to continue. We'll have somebody go ahead and get a hold of this Brian, try to answer his question, see what he's figuring out there. Next we have the canopy nip wheel gap. The gap needs to be set so the sheet can be freely fed and started. A good method is to set the gap by using feeler gauges and setting the wheel open to a gap of 150 thousandths. Now this is kind of a starting point. If you have thicker material, real thin material, obviously you can change it a little bit, but we found that this is a really good place for you to start and get going. Okay, let me go ahead and answer this question here from Brian. So he specified here, do we tighten the back stationary platen in the open position? We normally tighten it while the die is in the closed position. Okay, so the movable platen, you want to tighten the die set to. Okay, we're going to align that with your key or your Segan, and we're going to clamp that die to it. Okay, the stationary platen, we're going to loosely feed in those bolts until we've opened the mold, check for burrs and debris, and we're going to close the mold, enter the punches fully, and then we're going to go ahead and tighten those bolts down. And that just makes sure that whatever room we had, we floated those punches and dies in, and now everything is going to be as clean cutting as possible. And then we're going to clamp it down right there. So you're going to clamp it while it's closed, but first you need to stroke it open and then shut to allow that everything to line up and move into place so it enters true. Next, we have the canopy nip wheel pressure. The pressure needs to be set to just enough to get the job done. Oh, sorry, I see a question here on the specific torques. Now, it's all going to be dependent on the type of bolt you're using. Any torque recommendations, you're going to have to go ahead and get those from your bolt supplier. Okay, I mean, we use a type of bolt here, but it may not be the same thing that you're using or the same thing that they provide in different locations. So contact your bolt supplier on specific torques for sizes of what they're offering. So the first section here, the pressure needs to be set just enough to get the job done. Now this is on everything. We don't want to pump up the pressures on everything and try to run these machines. What's going to happen is you're going to push on everything so hard that you may cover up issues that you don't know exist. We want to pull the sheet just enough to get the job done. We want to insert the sheet just enough to get the job done. We want to sheet drag just enough to get the job done. We want to run these things just like they're meant to be ran, just nice and efficiently. Okay, we have these machines set up to be so smooth and so precise that when we crank up all the pressures on everything, all we're doing is battling to try to hold something straight instead of allowing it to go as designed and freely guide the stuff in and trim it out and go on its way. So if we're cranking up pressures, we're doing something bad. And if you have to crank up a pressure, something's wrong. We need to check it. It's like setting a tolerance. If you go above your high tolerance, something's wrong. If you go below your low tolerance, something's wrong. Too much pressure will cause premature wheel wear and dust. So if we got too much pressure on those wheels, we're going to crimp that sheet down and we're going to create dust. We're going to create those wheels to wear out. We're going to create issues. Not enough pressure and the sheet will not feed consistently, also producing dust. So this is the opposite, where you're going to have too much of a gap there, and we're going to be burning those wheels out on that sheet. We're going to create dust. We're not going to get a true feed, and we're not going to be able to get the positions exactly where we need to get them. Next here, we have the canopy nip wheel speed. The speed needs to be set so the inventory loop is easily and consistently filled. If the speed is set too slow, the loop will not fill, causing feeding issues and backfeeding. If the speed is set too fast, this will cause rippling in the sheet in the front of the wheels and can lead to jamming in the canopy. It could also cause the sheet to rip or tear. So if we're not feeding that sheet up our canopy in a manner that's consistent with a nice consistent run, what we want to see is we want to see that loop fill up and then pull down. Okay, loop fill up, get to the top, go down into the next shot. If we're ramming the sheet up there, well, we're going to overfill the canopy loop. We're going to cause it to have back pressure back down the canopy. It may even fold over to where you're trying to rip your product around, pull it through, create damage to your product, create cracking, create excessive wear on your components of your machine. And if it's not getting there in time, that's an even worse condition because we're forcing our treadle now to pull sheet up the canopy. It's just not designed to do it. I have seen in some cases where customers have disabled their canopy altogether. And this is a horrible, horrible thing to see because they're going through components in their treadle like crazy. We're wearing stuff out, all the bushings and guides, belts, all the drive units, the wheels themselves are getting worn out because they're trying to rip this sheet all the way up the canopy. So we really want to take time to set this stuff up. Those little things, pressure's just enough, the speed's set right. This is really going to help your process. Next section here, if the speed is set too low, oh, sorry, I already read this. All right, the sheet tammer pressure. Too much pressure in the sheet tammers will cause improper feeding with potential damage to the product and feed lugs. Not enough pressure can lead to the overfilling of the inventory. So this is the same concept. The pressure needs to be just enough. As it fills, we want those fingers to come up and raise that sheet up to the top of the canopy loop. And as it feeds, we want them easily to be pulled down. It's just enough to get the job done. With the sheet feeding up, it should be just enough to lift them up into place. Canopy guide setup. Guides need to be straight and in line from trim shot through the treadle and down to the infeed. Easiest method to do this is by filling the canopy, locking a shot, and aligning the guides into the treadle back. Avoid setting the guides too close or in a manner that can crush the feed lugs, cone locators, or the product. So what this is telling us is we want to fill the canopy, come down into our tool, and we want to lock in a shot, okay? So we're going to lock it in, we're going to close up that die, and the first thing we want to do is we want to inspect that product, okay? I want to make sure that the left side product has the same walls and outer lips as the right side product does. Top to bottom, corner to corner, all my products are exactly where I need them to be. So we can lock a sheet in, nip it, check it. If it's all looking good, we can go ahead and start to take our guides and set them into place. Again, we want them really close to the product, but acting as bumpers. We don't want them actually forcing the product into place. Anti-backup. These are designed to help prevent the sheet from sliding back when the canopy nip wheels are open. So these are just wheels typically at the very bottom of your canopy that only turn one way. They run on air cylinders that fire up and down. When they're down, so they can only turn one way, so they stop the sheet from going backwards. If the sheet needs to be removed from the canopy, these can be fired up to release it. Loop eye setup. Setting this too low can cause feeding issues and damage the feed lugs. Setting this too high can cause an overfill in the inventory loop and jam the press. So up at the top here, if we set too much loop or too much material ready for our next shot, well, we're not going to fully use all of that material. So it's going to be extra weight, extra material hanging up that we not only have to stop from going down our treadle, but we have to sit there and hold through the shot and still maintain everything. So we want to use our loop eye to set just enough to get the job done, just like everything else. We want enough sheet inventory to make the next cycle and not pull on the canopy. So it's something to take time and make sure that we're getting right. All right, next, we're going to go into this auto sequence with the auto thread feature. Put the trim press into auto cycle. So this is with no sheet, nothing in it. You can put the press into auto cycle. The sheet is fed into the canopy. So now you're entering your sheet into the canopy. Once the sheet blocks the canopy in-feed sheet detect eye, the ISDE, the canopy nip wheels will close onto the sheet, starting the sheet over the canopy. The auto load fingers and or bottom sheet tamers will fire down into the down position. The anti-backup blocks will fire down. The sheet guides will open. The servo nip wheels will open. And keep in mind that all selector switches need to be in auto mode. So prior to starting up without the sheet in there, all the selector switches need to be in the auto mode, center selection switch. The canopy nip wheels are in the low speed at this point. This is the speed controlled by a thumb wheel on the high volt box or in the HMI. The sheet will transfer over the canopy and into the sheet guides. The two-speed eye between the former and the trim press must be blocked or seeing sheet before the sheet will transfer to the two-speed eye. The two-speed eye will continue to control the sheet transfer until the canopy and treadle are full. So it's going to remain in this low-speed mode, and it's going to look for that two-speed or that eye in between your former and your trim press. And what we're trying to do is make sure that we're not instantly pulling that sheet out of your former. So we're going to wait for that to be blocked to continue that sheet up the canopy. The manual valve up on the catwalk that controls the servo nip wheels, open and close, must be in the closed position at this point. As the sheet is coming over the canopy, the sheet guides and the servo feed wheels must be in the open position, and this happens automatically. The sheet will then go into the guides until the treadle sheet detect eye, the TSDE, is blocked. This is the eye that is mounted just below the servo feed wheel. Now you got to pay attention to these guys because these eyes work in unison, okay? So if you're not seeing one, it's going to consider that circuit blocked. So the in-feed eye, the next eye going up, we really need to make sure that these are set right. And this is part of the setup process along with your pressures. We want to make sure that as soon as the sheet's going in there, it's seeing it. When the treadle sheet detect eye is blocked, the sheet guides close, the servo nip wheels close, the sheet tamer fires to the up position, and the blower turns on, and the canopy nip wheels change to the run or high speed. The canopy will continue filling until the top loop eye is blocked. So this is your inventory or your canopy loop eye. At this point, the canopy is ready for auto cycle. The servo feed wheels will now go into a search mode looking for the index lug formed in the sheet. So we have our upper two sensors made, and now we have our inventory loop made, and now we're going to start that sheet down into the treadle, and we're looking for that lug eye to detect its first lug. Once the lug is found, the servo system will do a backup move. This is a distance settable in the servo control screen or the HMI, putting the first part into position for the first feed. And this is important with this feature to take the time to set it up because it's really going to aid you in getting that first trim right. There's some products out there that are kind of touchy and they don't do well if your first product has got a bad trim to it. So we want to make sure that that first product's trimmed out right so the second product follows it and it just continues on through. The trim press will start. Once the platen is up to speed, the system will start feeding product into the trim press. If you're noticing that it's rotating a couple of times through before it actually feeds anything down, it's because that acceleration is set to a level that it might take it. Or if you have a high rate of speed, the acceleration takes a couple of strokes to get up to speed. And this is to keep your machinery from being damaged, okay? We want to get it up to speed, but we want to do it safely and efficiently to make your machines last. Note, if you have any problems with the sheet guides opening during the auto thread, the treadle sheet detect eye is not set properly. Again, these things work in unison. So if we're having problems where it's feeding over and all of a sudden you're hearing things open and close, it's your eyes. They're seeing, hey, sheet, hey, no sheet. And that's what's causing that. When the canopy in feed sheet detect eye, the ISDE, is unblocked, no sheet, the press will start shutting down. If a canopy blower is installed, you must select when the blower is turned off in the HMI. Turned off as soon as the ISDE is unblocked, turn it off when the press stops. If lower sheet tamers are installed, they must stay up during the shutdown sequence. So we want to kind of choose here what's going on. And this is kind of dependent on, for me, the type of grinding system that you have. If you have a grinder directly below, below your platen, you don't want that sheet to drop in because it can clog up or bind your grinder. If you have a grinder that's further downstream that just continues to pull that material through, then you're able to let it go for a larger amount of cycles. You can get more of that tail end of your sheet through. That way you can get more of the product out. Once the ISDE is unblocked, the system will start to count down cycles. This counter can be accessed in the HMI. You want the sheet to stop when it is in a full vertical state or just before the sheet guides. You do not want the sheet to fall out of the feed wheels. Now, even if you have a downstream grinder, you don't want to get to a point where that sheet goes past the feed wheels because then you're going to punch that die on the next shot that actually is not sure where it's at. We've lost control of the sheet, and you're going to have a bad punch. Your last shots are going to be half on, half off. When the count is made, the press will stop in its full open position. At this point, the sheet guides open and the servo feed wheels turn on, ejecting the last little bit of sheet out of the press. A few notes here. Canopy alignment is very important in the operation. It must be aligned so the sheet will start into the sheet guides during startup operation, but positioned so the sheet is getting pulled around during the feeding and running operations. If you have any problems like sheet guides opening during the run or the guides will not close during the auto feed startup, always check that both sheet detect eyes are properly set. This is very important as all functions are keyed off these two eyes. So we kind of went over this a few times. If you're seeing odd things where things are opening and shutting and you're wondering why that's happening, we need to check these eyes. The top rods that fire down on the canopy are to guide the sheet into the sheet guides. These must be set between the rows of parts. The best way to set these is to lock a shot of foreign parts into the trim die, and this will give you proper alignment on the rods. Okay, so everything going through this tool depends on these parts being in your die centered. So we always want to start setting this stuff up with a shot locked in and check your product for quality. We want to make sure that everything's consistent, even if we didn't go too far, not far enough. Didn't see many questions during that. I try to go over everything, but if you do have any further questions, feel free to chat them here. And again, if you want more, get with our sales at brownmachinegroup.com. They'd be happy to jump on and go over your specific machine type with you and be able to give you some more information on that. The next saddle here, we're going to go over a little bit of the treadle setup itself. We're going to go over the sheet line position, the stroke amount, the treadle setup of treadle stroke amount with rocker arm, sheet guide open, close setup, sheet drag, guide finger position, quick change guides, and feed stroke and adjustment. Sheet line position. This is set by moving the treadle so the sheet guides will place the form sheet against the face of the trim die on the stationary shoe. Okay, so these are going to be your arms up top that we can check the forward and back position and also the stroke amount. The stroke amount. This is determined by the height of the product. An adequate distance is necessary between the form part and the trip die. The setting between the product for the height is going to be dependent on two things: the depth of the product and the time that you're going to have to index the next product through. Sheet guides open and closed. When the sheet guides are in the closed position, the sheet should be able to move through with minimal resistance. When the guides are in the open position, the sheet should fall through freely. Caution: if the gap is set too large, it is possible that the tooling may hit the back of the rear sheet guides, causing damage. So we want this, when the sheet guides are open, we want it just enough, let that sheet fall through nice and freely. And when they're closed, it's just about touch that sheet, okay? Even with the sheet guides closed, my rule of thumb is, even with the resistance on there, the sheet drags, I should be able to grab above the treadle and push that sheet down, okay? I shouldn't be folding it over. I should be able to push it down, and as soon as I let go, that should stop. And what that does is it shows me, hey, I've got just enough to get the job done. When I'm done feeding this sheet in, it's gonna stop. I'm gonna be able to trim it out successfully. If you have too much resistance, it's hard to pull that stuff through there, and then we're gonna have to turn up the pressure on our nip wheels. So they kind of work in unison. You want to make sure that all of it's just enough to get the job done. The sheet drag. This applies drag to the sheet to control the sheet during final positioning of the feed move. So again, we want to set this sheet drag just enough that it stops that sheet. But if I reach above it and I've got a foot of gap above the treadle that I grab that sheet, I should be able to pretty easily slide it down and not kink that sheet over. If I can't, it causes a lot of resistance, something's going on, whether it be your sheet guides or your sheet drag that's causing issues there. Guide fingers. These are used to stabilize and align the sheet. Set them on the outside edges and between the parts as spacing between punches allows. The quick change. Fast and easy adjustments to positioning and installation / removal of guides. This is a kind of a cool feature, because we're just pulling out a couple pins. You're able to grab that whole thing and rip it right out of there. So if we need to, we can pop that stuff out of there, get it out of our way, change our tool, throw them in, or throw a next set in to a different mold that's already set up, so we don't have to keep moving things back and forth. It takes a lot of time out of your process if you take the time and spend a little bit extra to get the stuff you need for each die. Feed stroke. Set the length of the stroke by measuring from lug to lug and adding a ½ inch. This is the distance over the index line if using a non-equal index tool. If the feed stroke is affected by the pusher finger lengths, this is fine-tuned by using the up and down feed length switch. Okay, so what we try to do here is the feed distance plus a ½ inch. Because we want to come over, even if you're using the pusher fingers to come down on a feed lug to push it into place, we want to go about a ½ inch above it. If we started getting in excess of a ½ inch, what you're doing is you're allowing that to come down at full speed. We don't want to do that because it can rip your feed lug right off. So about a ½ inch is enough to get out of its way when we're doing our trim, and then come down and touch it before getting up to full speed, where it can cause damage to your sheet, and then you'll get an inconsistent feed, or it'll bind up and stop feeding altogether. Next, we have a little bit on the servo treadle setup. This is kind of machine specific, so we just want to throw this little tidbit out there. If you want more information about it, we have more. So email us at salesbrownmachinegroup.com and we'll get this out to you. The servo treadle assembly consists of a servo motor, a gearbox, and a drive shaft with which drive a pair of connecting rods attached to a servo flex feed cage. The Treadle servo motor is programmed to follow the signal from an encoder on the main drive flywheel. This synchronizes the treadle to the main drive. The servo controller and operator interface are mounted in an electrical enclosure located next to the machine. The biggest advantage of the servo treadle actuator is that it can be very accurately programmed to pilot straight walled parts into the dies. If you got something that needs extreme accuracy, is extremely delicate even, this is not just rolling sheet through or grabbing it and sliding it into place. It's really accurate, it's really efficient, and we've seen people do really well with it. So on your treadle motion adjust, what we're going to show here is this easy file diagram. Most of our machines, this is a plate stamped close to where you can read it, where you're actually going to be making this adjustment at. Okay, so what we're going to show here is that the pivot arm holes. Okay, if you go to hole number 1 and you have a platen stroke of 4.5 inches, your treadle is going to move 0.9 inches. Okay, we just follow this through. If we're going to move it to our last hole, 8, and we're going to stroke our platen 13.5 inches, we're going to have a treadle movement of 7.4 inches. And that's all that's showing. It's an easy follow chart to be able to know how far you're moving your treadle. Now would be a great time if you guys want to go over some more questions, shoot them in the comments and we'll try to go over those, you know. We want to hear from you. We'd really like to hear from you. Email back these one-on-one conversations. They can be extremely productive. I'd love to kind of give everybody the information. If you got a question, they might have the same question. So feel free to comment it in the box below so we can answer that out. So I got a little slide here I want to share with you because this is another one of our companies that we're just extremely happy with. They do a great job. It's Freeman Tool and Die here. They have generations of experience as pioneers of the thermoforming technology. No one brings more experience than the BMG group. With quality and consistency, our rigorous quality control and work processes ensure that your tool arrives and it's ready to run. Okay, we do a really good job of this. Just the time, the quality that's put into these tools, the verifications, it's great. It helps us out big time. I got a question here. Do you have similar webinar covering Lyle intermediate process? We're going to keep putting these webinars out there. As far as we can see right now, people are liking these, people are enjoying these. And if you guys are enjoying these, please throw it in the chat box, email us at the sales@brownmachinegroup.com. Tell us how we're doing. You know, even give us your opinions. If there's something you want to hear about, talk in and see when that might come up. We're going to keep throwing these out there, and you may just see one on the Lyle Intermediate Press. We have some more advanced stuff that's going to come out. These are back to the basics, kind of just getting going, setting up, as you've seen, the simple things to getting a process up and running. So if you want to see more, comment in. We have tooling for every brand of machine. We have a fast turnaround time. From complete tools to change parts, let BMG provide you with effective solutions to fit your needs. We have turnkey solutions. You can pair your project with any other of the support services. Have your tool installed, train your operators, and repair your machine with one company, Brown Machine Group. And this is big, guys. If you keep your stuff under the Brown Machine Group umbrella, we're able to get you start to finish. You know, with your tooling, with your machine, you're able to get somebody like me to come in there, install it, help you set up, make sure that there's no bugs, everything's right the first time, and also train your people. New equipment, new molds, new training, new processes is really important to a successful operation. This Freeman Tool and Die, I mean, they do a lot of things. They go above just building the tools here. They do a confidential testing and validation. They do prototyping. They do acceptance trials. They come help optimize the cycle times, and they're really good at that. We got a great guy that you can get in touch with and talk to, Seth Dickman. Every time we reach out to him, he's a great guy, really does a good job. here, if you saw our last webinar, we went over this, and we're going to do it again because we have some really good stuff here. Okay, we have critical spares. We can get you set up with a spare parts list, discrete services, and one in and out. If you just want us to come help you with something and be on our way, we can do that too. Preventative maintenance and training. This is huge. It's something I personally been working on, along with a couple of other of our great Brown representatives. This is huge. We go out there and we do this training. We right down to the oil samples of your machine, checking for any kind of metal flakes. We do a great job at trying to get you trained to help your maintenance staff learn how to take care of these machines, keep them running longer, keep them running more efficiently, and help train your operators as it comes into what they need to look out for, what they need to watch for, what they should listen for. This is a great one. Remote services, this is really blowing up, especially with this COVID stuff. This is one of the services that we're really trying to help people with. It's our way of reaching out, just like this webinar. We're trying to do our part, and this remote services is huge. We're able to reach out, see what your machine is doing, get a call, and maybe help you just diagnose something without actually having to send one of us out of the field. Again, if you got any more questions, email us at the sales@brownmachinegroup.com. We'd love to hear from you. We want to know if you want more. I hope you've enjoyed this presentation. I'm not seeing any more questions, so I'm going to go ahead and end this for today, and let us know what you think. Thank you so much. Bye-bye.